Now this is question number 36, objective solved example functions. Now two functions are given in this question. Fx is given like this and gx is given. Gx is max of 1 comma mod of x minus 1. Now first of all let's plot gx. So gx is defined as maximum value out of 1 and mod of x minus 1. So generally in these questions we plot all these functions. We plot mod of x minus 1. This is mod of x minus 1, plotting mod x and then shifting 1 unit towards right. And then one line. This is one line. Y equal to one line. Now we move from left to right and see for every value of x which one of the two is greater, 1 or mod of x minus 1, and take the greater of the two. Right, so we start from here in the negative half. You can see throughout this mod of x minus 1 is greater than one line, so we choose this. But at x equal to 0, mod of x minus 1 is going down and 1 is becoming greater than mod of x minus 1 till this 2 value. At 2 again mod of x minus 1 moves up more than 1. So at every value of x we have taken the greater value out of the 2. Out of 1 and mod of x minus 1 we have chosen greater value for gx, max value for gx, that is this superimposed graph in red. So we can draw it separately. This is graph of gx 0 2 till this is constant in between 0 and 2. This is 1 minus x, this is x minus 1. Fine. Now if you look at fx is we have to compare 1 plus sin x, 1 minus cos x and 1 and take the maximum of the 3 and assign it to fx. Now let's see how to draw 1 plus sin x. You know sin x graph. This is sin x graph. 1 plus sin x means we have to shift this 1 unit up. Right, we have to shift 1 unit up like this. 1 minus cos x, you know cos x is this, minus cos x means we have to invert this in x-axis. This is minus cos x. Minus cos x plus 1 means we have to shift minus cos x 1 unit up. Right, so this is 1 minus cos x graph. This is 1 plus sin x graph, and you know 1 is the horizontal line at intersecting y-axis at 1. Now if we combine these three graphs on the same scale to compare which one is greater, we'll come up with this situation. We'll come up with this graph where all the three, 1 plus sin x, 1 minus cos x and 1, are plotted on the same scale. You can see red one is 1 plus sin x, black one is 1 minus cos x, and this blue one is one line. Now we'll move from 0 to 2 pi and see which one is greater of all the three. So if you just start from here, out of the three you can see 1 plus sin x is greater. We'll choose 1 plus sin x. But at 3 pi by 4, where the two curves 1 plus sin x and 1 minus cos x are intersecting, the situation is changing. 1 plus sin x is going down and 1 minus cos x is becoming greater. Goes on, you can see more than the other two. 1 minus cos x is more than the other two, but till only 3 pi by 2, where the greater of the three is the horizontal line 1 till 2 pi. Right, so if I draw the graphs separately, this is the graph. Till 3 pi by 4 it is 1 plus sin x, and then 1 minus cos x till 1, and then horizontal line 1. So you can, if you just have to see the range of this graph, it lies between 1 and 2, right? 1 plus sin x, 1 minus cos x, and 1 if we combine together with the max operator, you can see the range is between 1 and 2. Graph lies between 1 and 2. Now we have to find, in this question we have to comment on g of fx. That is, first of all, x goes to f function and output f goes to g function to get g of f. Now you can see if the range of f, if x belongs to r or x belongs to 0 to 2 pi, yes, that's an interval, is given to f, the output of f will lie between 0 and 2 pi. The output of the first box is between 0 and 2 pi, right? Oh, sorry, 1 to 2. Output of the box, repeat this, if I replace x belongs to 0 to pi to function f, whose graph we just discussed, this is the graph of f, the output is between 1 and 2, the range is between 1 and 2, right? And when this range, that is the values between 1 and 2, are fed to this g block, we need to figure out what is the final outcome. When 1 to 2 is given to this as input, this is the graph of the second g block. 1 to 2 is fed to this c between 1 and 2 as input, it throws output equal to 1. So g of fx will always be 1 irrespective of input we give it to this, and we can check it here once again. Input you give to f, that is this, between 0 and 2 pi, the output will be somewhere output will be any value between 1 and 2, and when you give 1 to 2 value to this, it will throw output 1. So that's why for all x between 0 and 2 pi, the output of this combined composite function we say is 1.